using which name node has stored the data. In actual, there is nothing present in as a actual data with the name of employee.csv. With actual data, there is blocks are stored. Uh, so if someone asks like the if there is any file stored employee.csv, so this is not an actual file. This is just a name that name node has created for the blocks that are stored under the hood on the data nodes. We are just using this name to query those blocks. Okay, we are just using this thing to basically query the blocks that are stored on the data nodes. Okay, so this is what I wanted to understand, explain. Okay, so now one more thing. So we have understood like we can copy the things from our local to HDFS and HDFS to local, so that is fine. Now what if we want to copy copy the files from basically within with files from one location to another but within HDFS. We can also do that, or we want to, instead of copy, we want to move the file from one location to another within the HDFS. So for copy, you just have to you have to use the prefix. What is the prefix? HDFS DFS or Hadoop FS with hyphen, and now you can use your normal Linux command. Like for copy you have to use cp, and now you have to mention the path. So for example, what is the path? Basically, let me come here and check what I have. So I have this data thing. What I can do, let me create mkdir new data, and now if I check basically, sorry, I forgot to use hyphen. So now I have the data and the new data, two folder inside my HDFS. In the data I have my employee.csv, and I want to basically copy that employee.csv to the new data folder. Okay, I want to copy the file from SDF data folder to new data folder, which is like both folders are present inside one HDFS. So what I can do, data.employees.csv, and the target would be new data. Okay, so I want to do this thing. So let me go here and do the same. So it worked, and now let's check what is there inside new data. So inside new data you have this employee.csv file. Okay, so we have copied it, so this is fine. So now what we will do, we will move it. We will use the same command, and we'll just instead of cp we'll use mv. So what I'll do, let's say I want to move it to, let's say, new data 2, HDFS DFS hyphen mkdir, and I create new data 2 folder. And now from new data I want to move this file from here to new data 2. So how I will be doing it is from new data I want to move it to new data 2. So normal, simple, just copy paste, and it worked. Okay, so let's go there and see what is there inside the new data 2. So we have the file, and if we check the new data, it should be empty because we moved it from here to new data 2. So it worked. So this is also worked. So now the thing that, so these commands are like very basic. This will not be asked in the interview, but the things that will be asked in the interview would be like, what is the difference, like which command will take more time and why, which command will take more time and why, which command will take more time and why. Which command basically? Between move and copy. So in these two commands, you have to tell like which will take more time and why the one will take more time. So let me give an example. So if I go here, I've already created an example for you guys. So it is a kind of detailed answer. So let me explain this. So what I basically did is, let's say we have a customer, this file present that has, let's say, size of 512 MB, and we have the four blocks that we know. Okay, fine. And it should be, let's say, it would be user / username. Okay. So because in the HDFS you have you have to use this user / username as a home directory, and then inside the data folder we have this CSV file which is of size 512 MB, and we can create four blocks because each block will be having 128 MB size. That is fine. So what basically I'm doing is, let's say I'm trying to move this file from data, basically copy this file from data folder to, let's say, some archive folder. There is some archive folder is also there. So what I'm doing is I'm copying this file from data to this archive folder, okay. So it will take more time, and if the file is used, but why it will take more time, let me tell you. So before copy command, so before doing the copy, what would be the scenario? Let me just, so before copy command, so before running the copy command, this would be the scenario in the name node would have this mapping with these four blocks, which are stored on this data node, let's say data node 1 2 3 4. But after you run the copy command, what will happen is after you run the copy command, this earlier this basically, this is the one metadata that was there earlier, so it will be there as it is because we have copied the file. And when we copy the file, a new copy is created basically. So now we have two copies. So in metadata, in the name node, it has basically have the older mapping also, and it has created a new mapping. So new mapping is like in archive data, it has, let's say, these customer.csv, and now these new blocks are created again. This will create a new blocks for this file. Basically now we will be having 8 blocks, one for the 4 for the new file and 4 for the older file. Okay, so it has mapped this path to these blocks which are present on some data nodes, let's say 1 2 3 4. So now we have two files which is present inside the archive, and another is present inside the data, and these are mapped with the different blocks files which are present on the data nodes. That we understood. Okay, but why it took time is basically it has to create new blocks. For the copy, because we are creating a new copy, and for new copy it has to create all the 4 blocks again which was there earlier. So that's why it is taking more time. It is creating new blocks. Okay, but what will happen in the move case? Instead of doing the copy, if I do the move, if I move this file from data to the archive, it will take very less time, because now when we do the move, only we still have the one copy. When we move, we still have the one copy only, and we do not have to create the another copy or another new blocks. We don't have to create the new blocks, because we are just moving the things. So what would happen is, like before move command, if you see, so this is the mapping that would be there, data and these blocks which are stored on the these data nodes. This is the metadata. This is the kind of metadata which is stored inside this name node. Okay, this is the metadata which is stored inside this name node. Like this is the file which is stored in these, like this is stored as in the form of blocks on these data nodes. But when you do the moving, after running the move command, what it will do is basically name node will basically delete this mapping, basically update this mapping only. instead of creating new copy, it will be updating this mapping. Instead of doing keeping this as a data, it just changed, updated it as an archive, because we, what we did is we moved it from here to here to archive. And when we move the things, we do not have to create a new copy. Okay, it will use the older blocks, these locations only. These, if you see, even we have the archive here, the inside the data nodes, these blocks are like the older blocks are only, you know, referred. If you see the data, only the older blocks are referred. It had just updated the left side, the mount point is at it has updated. So here it haven't done any, you know, heavy lifting, or you know, it haven't created any it hasn't created any new blocks. So that's why it is, the move command is faster. It has just updated the meta table with the new mount point. There is nothing concept called mount point. I'm just, you know, to make you the, you know, to make the things simple, I'm using this mount point. Okay, there is nothing called mount point concept in the HDFS. For the simplicity, I'm saying this. Okay, this is kind of mount point. It has, you know, mapped this mount point to these blocks which are stored inside the data nodes, and this is the metadata. Which is stored inside the name node. And these blocks, these you know, these files are stored on the these data nodes. Actual files. These are the actual files. This is just a naming convention to basically help us to retrieve or manage our data which are stored on the data nodes. There is nothing called customer.csv actual which is stored on HDFS. In actual, our customer hive underscore block 1, block 2, block 3 are stored. There is nothing. It is just a kind of naming convention that we are using to access these blocks. So hope you guys have understood, and if you still have any doubt, let me know in the comment section. I'll you know, try to clear those your doubts. So this is what I wanted to explain, and so that is fine. So now there is like one more command is there. For example, now if you have this file, let's suppose you have this file. Take this example only. If you have this file, stored you know, on your HDFS, and these blocks are stored on, you know, some data nodes. So this thing I have taken just for example. In actual, this you know, might be some different, you know, internal location that data node has stored the file on, so that will be different. But now if you want to see, so for example, HDFS DFS, let's say inside data I have something. So basically I want to know the blocks, like where the blocks of this CSV file is stored on, and on which data nodes I want to see that. So there is a command using which we can do that, and we can basically see what all blocks are basically created for a particular file, and where these blocks are stored on which particular data nodes. So the command is HDFS FSCK file system check. So it is just checking, okay, your file system to look at where the blocks are stored. So this command will only go to your name node, and name node will tell, okay, these are the paths. So this command will not go to your data node, and it will be, you know, very fast. So FSCK, and now we have to give the path. So what is the path? Let me take this path. And what we want to basically know is we want to check the blocks, we want to check the files, and we want to check the locations. So these are the three things that we want to check. So if I run this command here, I basically have to give the locations, and so I'll just use this, and let me see what we will be getting. Okay, so we got this information connecting to the name node. So as I just mentioned, it will only go to the name node, and name node has the metadata, like which where the blocks of this file are stored, and on which data node, and name node only will be able to tell this the information that we need. So name node would have return the result to our gateway node, and this is what we have what we have received from the name node. So if you see, we are checking this particular file which is of this bytes. So only one block will be created, because uh, for one block the maximum, the size is 128 MB, and this is less than the 128 MB, so we'll be having only one block. So the replication factor is 3. So basically the 3 copies of this block will be created on the data nodes. So if you see, like this is the block ID it has generated. So 0 is nothing but, so it like start from 0. If you have, let's suppose, two blocks, if you have two blocks, let's suppose the size would be, if the size is here is, let's say, 128 MB, let's say 256 MB, something like that. So there will be like two blocks would be created, and so you here will be having 0, and another will be starting with 1. So it is starting with like from 0 indexing. So it has created, for this use case, it has created only one block, because the size is only 535 MB, sorry, 535 bytes. So it can it can fit inside one block size, which is 128 MB. So it has generated an block ID. So this is the block ID it had generated. This is the block ID, and this is the information of the data node. If you see, it has given me the data node IP with the port. So on this data node, this particular block has saved, and the another copy of this particular, like, we will be having 3 copies, because 3 replication factor. The another copies of this block are stored on the second copy, is stored in this particular data node, and the third copy is stored on this particular data node. So this is how you can see where all the blocks of your file are stored on which data nodes. So this is how you can look at this. And if you see, it is saying there are total 3 data nodes that we know, only one rack. I have already explained the concept of racks in my HDFS architecture session, and it also has given me some details about like the size of the file and more details. So this is the main thing that I wanted to explain, and I hope you guys understood the same. So we can use this command to basically check how we can to basically check the where all our blocks are stored, and on which data nodes those blocks are stored, using the file system check command. So that is fine. Okay, that is, so we have covered a lot in this particular session, and so I hope you guys are like understood most of the things. And if you have any doubt or anything, let me know in the comment section, and I'll try to resolve all of them. Okay, so yeah, that's it for this session. We will meet in the next session. Thank you.